In this video, we're going to solve the 2001 AP Calculus AB FRQ question. It says the temperature in degrees Celsius of water in this pond is a differentiable function W of time t. The table above shows the water temperature is recorded every 3 days over a 15-day period. Use data from the table to find the approximation for W prime of 12. Show the computation that leads to your answer. Indicate the units of measure. Okay, pretty straightforward. So for part A, if we want to find W prime of 12, we just need to find the slope. So the easiest way is probably W15 minus W9 over 15 minus 9. So W15, what is that? 21. W9 is 24 over 6. So now we're going to get negative 3 over 6, which is negative 1/2 degrees Celsius. What is it per day? Yep. So it's dropping half a degree a day on average. B, approximate the average temperature in degrees Celsius of water over the time interval 0t to 15 by using a trapezoidal approximation with subinterval lengths of 3 days. Okay, so there's a lot of stuff going on here. We want to find the average, and we want to use trapezoidal approximation with t equals 3. So they gave us the thickness. That's the good part. So I'll do it up here. So we want to find the average. So we have to have 1 over 15 minus 0. Okay, times 3 over 2, because that's a formula. It's n over 2, right? And now when we do this, I don't know if you remember trapezoidal, the first point is always as is, but all the middle points are always twice as much, right? So now when we write this, we're going to do 1 over 15 times 3/2 times, what is it, 20 plus 2 times 31 plus 2 times 28 times 2 times 24 plus 2 times 22 plus just 21. The endpoints are always as is. So now, when you solve this, you're going to get 1 over 15 times 376.5, which is equal to 25.1 degrees Celsius. So that's the average temperature. Average temp. Okay, so now, part C. Let me just box this off so it's not in the way. Part C says a student proposes a function p is given by p of t is equal to 20 plus 10 te to the negative 10 divided by 3 is a model for the temperature of the water in the pond at time t, where t is measured in days and p of t is measured in degrees Celsius. Find p prime of 12. Using approximate units, explain the meaning of your answer in terms of water temperature. Okay, so that's pretty easy. So let me move that away over here. So if we want to find p prime, we need to take the derivative, right? So let me just erase this part. So p equals 20 plus 10 te to the negative t divided by 3. So now, if I want to find the derivative of p, I'm going to write p prime. Derivative of 20 is 0. Derivative of t is 1. So you're going to get 10e to the negative t divided by 3. Plus, because it's a product, you write the 10t, e to the negative t divided by 3. But the derivative of negative t divided by 3 is negative 1/3. So let me move this. So now let me simplify. So now I'm going to get 10e to the negative t divided by 3 minus 10/3 te to the negative t divided by 3. Now I can plug in the 12. So when I plug in the 12, I'm going to get 10e to the negative 4 minus 10 thirds times 12, e to the negative 4. So this is 120 divided by 3 is 40. So let me just draw an arrow. So now I'm going to get 10e to the negative 4 minus 40e to the negative 4, which is now negative 30e to the negative 4, which is approximately equal to negative 0.549. Now we have to use the units. This was degrees Celsius, so this is the rate at which it's dropping. So the temperature is decreasing at a rate of 0.549 degrees Celsius per day at T equals 12. So basically what you just found here is the instantaneous rate. Okay, part D. Use the function P defined in part C to find the average value of degrees Celsius of P over the time 0 to 15. Okay, so it says average, right? That's important. So we're just going to do 1 over B minus A. So when you do this, it's 1 over 15. The integral 0 to 15, P of T, right, dt. Plug that into your calculator. And when you solve this, you're going to get 25.757 degrees Celsius. Okay, I hope this video helped, and I will see you next time.